Okay, guys, as I was looking around, I saw good things for number 1 and number 2. Number 2, many people saw you could factor by grouping. So you go on to solve and you get -2 and plus or minus root 3. I wanted you to kind of wrestle through number 3 and see, is there anything I can do to factor this down or to find the possible zeros? At this given point, there's 5 terms. We haven't seen any methods for factoring 5 terms. In fact, to be honest, I'm not sure if there is one. But what if I give you a hint? So what if I give you a hint on number 3? If I tell you that the function does have a 0 at x equals -1, could you find the rest of the zeros now? Charlie, what would you do? So if x minus 1 is a 0, therefore we know that x plus 1 is a factor, right, guys? So how could I take x to the 4th minus 6x cubed plus 4x squared plus 15x plus 4? How can I take it and divide it by x plus 1 easily? Synthetic division. So let's do that. We just practiced it a lot in our homework. So what number would I put in the box? A -1. And I would have 1, -6, 4, 15, and 4 to line up. What's the first step? Bring down the 1. And then -1 times 1 gives me -1. -6 plus -1 is -7. -1 times -7 is +7. 4 plus 7 is 11. -1 times 11 is -11. 15 plus -11 is 4. -1 times 4 is -4. 4 plus -4 is 0. So what did I find? I found another factor. So if I put this back into the answer form, what would I start with? It would be 1x to the what? To the 2. How'd you know? Careful, I took cubed. Okay, good. Cubed. And remember, that's because you're taking an x to the 4th and dividing it by an x. So you're going to answer with an x cubed, and then we trail down with coefficients of -7x squared plus 11x plus 4. Can we factor this? Let's see. Can I factor it? I'd have to factor by grouping. I'd take out an x squared, copy over an x minus 7, and bring it over to the other side, but the other side can't maintain that GCF. Okay, so I'm going to need another hint. Notice, do you need another hint? The function also has a 0 at 4. Can you find the rest of the zeros now? Well, what would we do at this point if we know there's another 0 at 4? More synthetic division. If x equals 4, then we know therefore x minus 4 is a factor. But what would my synthetic division look like? What would my process? The 4 would be in the box. And what am I dividing that into now? Yeah, this one here. Because right now, I know that x plus 1 is a factor. I know that this is a factor, and I have another 0 value. So I'm going to divide this into here. So I'm just going to show what I'm doing off to the side. I'm going to take x cubed minus 7x squared plus 11x plus 4. And I'm dividing it by my factor that was given to me by another hint. So I line up those coefficients of 1, -7, 11, and 4. Bring it down. And I bring down the 1. 4 times 1 is 4. -7 plus 4 is -3. 4 times -3 is -12. 11 plus -12 is -1. 4 times -1 is -4. 4 plus -4 is 0. So my answer, well, where am I going to put the 1 into now? What's it going to be a coefficient of? X squared, because I took an x cubed and divided by an x. So I have 1x squared minus 3x minus 1. Now, just to kind of show you what I have, I took the big polynomial, which was at the top, x to the 4th minus 6x cubed plus 4x squared plus 15x plus 4. And that was equivalent to my two factors, x plus 1 times x minus 4 times this guy right here. So we know that we have zeros of -1. We know we have a 0 of 4. Can I factor this guy here to find the other zeros? No, it's not factorable. So here's your last hint. How can you solve a quadratic? Notice it's a quadratic because it's a squared, if it cannot be factored. Yes, quadratic, you're close. You said formula, quadratic formula. Yeah. So here, to find what x equals, I have x squared minus 3x minus 1. I'm setting it equal to 0. I'm going to use that quadratic formula. So x equals what? Some of you are singing Pop Goes the Weasel in your head. X equals negative b plus or minus square root b squared minus 4ac all over 2a. You guys learned it? Some of you maybe Pop Goes the Weasel. Some of you are like, my math teacher is so weird, but it comes with the territory. So x equals the opposite of b, -3, plus or minus square root of b squared, -3 squared, minus 4 times a, which is 1, times c, which is -1, all over 2 times the value of a. So that would be 3 plus or minus square root of 9 plus 4, all over 2. And so that would come out to be 3 plus or minus square root of 13 over 2. Yeah, you guys check me on my algebra? That's good. Okay, so how many solutions did we have? 3. Well, careful. We have 1, 2, 3, 4. 4. Now, just to lead into tomorrow's lesson, what was the degree of the starting polynomial? 4. So just kind of keep that in mind. But let's go ahead and let's take these observations and go to the next page. Okay, so I gave you some hints that helped you finish the problem. How can you find the zeros of a higher degree polynomial function if you cannot factor and if there are no given hints? Well, here's where the rational zero theorem comes in handy. The rational zero theorem gives you your hints. But one thing to be aware of is it gives you possible zeros, not actual zeros. So the rational zero theorem gives you a list of possible rational zeros, and they can be found using this formula. The factors of the constant term over factors of the leading coefficient are possible zeros. They're possible hints, but you have to determine which of the numbers are an actual zero. So first, let's see how to do it, how to determine what the possible zeros are, and then we'll see, well, which ones are actual zeros. So consider this polynomial. We obviously have to use this formula above. What would be the factors of the constant term, which is just the 2 there? Or you could see it as a 2 or you could see it as a -2. You'll see why it doesn't matter in the end. What are factors of 2? 1 and 2. Could it also be -2 and -1? Yeah, so you have to list the negative values as well. That's why it actually doesn't matter if you're looking at it as a -2 or a +2, because all factors are going to just simplify to the plus or minus 2 and a plus or minus 1. Okay, how about factors of the leading coefficient? That's the coefficient of the highest degree term. Why do we say 1? Because if there's nothing there, it's understood to be a 1. 1 times anything keeps that value of the number. So what are factors of the number 1? 1, 1, and -1 and -1, right? So you've got to take into account both of them. So it would be plus or minus 1. So what are all the possible rational zeros? Well, it's factors of the constant, so the blue ones that I have on my screen, over factors of the leading coefficient. So it would be plus or minus 2 and plus or minus 1, all the combinations of that divided by plus or minus 1. So how many possible zeros did this theorem give us? Yeah, either well, is it really 4? Because you could look at it as 2 over 1, but then you could look at it as negative 2 over 1. Those are all the possible combinations. Or you could look at it as 1 over 1, which is just 1. Or what's the last one? Negative 1. Now, these are the possible zeros, 2, negative 2, 1, or negative 1. How can I decide which, if any, are actual zeros of the function? Because notice it said possible. If you get a remainder, right? So we could use synthetic division. Or what Olivia said, the remainder theorem, which essentially just says if you have your function and you plug in that value, if it comes out to equal 0, that's the remainder theorem. Will the function come out to be a 0 value? The easiest ones to test, if you have whole number values, are 1 and 2 first. More than not, it will be either 1 or 2. Not always, but more often than not. So let's go ahead and let's test. Which ones do you guys want to test first? Jeremiah, what'd you say? I saw your mouth. 1 or 1? Okay, let's test 1. How do I test it, guys? Line up the coefficients of the polynomial I'm dividing into, right? So that would be a 1, a 4, a 3, and a negative 2. So 1, 4, 3, negative 2. Bring down the 1. 1 times 1 is 1. 4 plus 1 is 5. 1 times 5 is 5. 3 plus 5 is 8. 1 times 8 is 8. Negative 2 plus 8 is 6. What does that mean about 1? Didn't work. Okay, what else do you want to try? Negative 1 or 2. And if you and your partner are together working on one of these, one of you could try one, the other could try the other. Why don't you do that? Why doesn't one of you try negative 1 and the other one try 2? All right, guys, what did you find about 1 and 2? 2 didn't work. 1 didn't work. What do you think would be the next best case to try? Negative 2. So, of course, this is the one. But aren't you glad that we were taught synthetic division, so we don't have to do long division with all of these? I like synthetic. Okay, so I'd line this up. Pretty sure this is the one that's going to work. Bring down the 1. 2 times, or negative 2 times 1 is negative 2. 4 plus negative 2 is 2. Negative 2 times 2 is negative 4. 3 plus negative 4 is negative 1. Negative 2 times negative 1 is 2. And voila, I get a remainder of 0. Therefore, I know that this function factored down is going to equal, well, if this is a 0, then what do I know is a factor of the function? X. So negative 2 is a 0. So, yep, so x plus 2 is a factor. And then if I put this back into factored form, or into the function form, x squared plus 2x minus 1, can this be factored? X squared plus 2x minus 1. The last term's negative, so that means I'd have to have different signs. So if I have a plus 1 and a negative 1, unfortunately it can't add up to be 2. So how can I find the zeros, though, if it is a quadratic? quadratic formula. How many zeros? We know that one of the zeros is -2. But how many more are we going to find? 2 more. Awesome. Go ahead and solve the quadratic formula on your own. You can check your work up at the screen. All right, guys, go ahead and check. Hopefully you simplified at first, to -2 plus or minus radical 8 over 2. But radical 8 can be simplified to 2 root 2. And then I see a factor of 2 in every number, so I can divide it out. You can see my work kind of off to the side here. And so my answer simplified would be -1 plus root 2 and -1 minus root 2. Okay, that's the new content. This back page kind of brings it all together. You have a polynomial. It says find the possible rational zeros, so use that rational zero theorem. You're going to factor it all the way, and actually just stop when you get here. And then we'll bring your knowledge from prior sections all together with graphing the polynomial as well. Okay, so with your partners, go ahead and complete this. Okay, guys. Some of you are asking good questions. You're asking, will there only be one that works, or could there be more than one? I've already heard across the classroom. Some people say 2 works. Some people say -1 works. So, depending on which one you have that works. If I know -1 works, and let's say that I had a partner and she tried 2, and that one also worked. If we found 2 zeros, x equals -1, therefore we know that x plus 1 is a factor. And furthermore, if I found x is equal to 2, therefore I know that x minus 2 is a factor. So what I could do here is, for example, I have these leftover numbers. If I took my polynomial and divided by x plus 1, I would be left with 2x to the third minus 9x squared plus 12x minus 4. How could I take my partner's knowledge, that 2? I can divide again, exactly. I can divide 2 into this leftover polynomial, 2, -9, 12, and -4. Bring that down. 2 times 2 is 4. -9 plus 4 is -5. 2 times -5 is -10. 12 plus -10 is 2. 2 times 2 is 4. My partner's right. That's a nice way to check it. And then this is my remaining piece of the polynomial. So right now I have x plus 1 times x minus 2 times 2x squared minus 5x plus 2. So this is the factored form. X plus 1, x minus 2, and then 2x squared minus 5x plus 2. Now these are the only 2 I've heard across the classroom that work, 2 and -1. There are others that work, but what if I just stopped here? What if I had only heard 2 and -1 works? Is there anything I could do just from my prior knowledge to help me continue factoring this? Can we factor something with 3 terms? Sometimes. Let's see if it works. If I break this apart, the last term's positive, so I know that means I'm going to have the same signs, same as the middle term, negative and negative. 2x times x would give me 2x squared. And then if I place a 2 here and a 1 here, then that will add up to my middle term. Negative 4x plus negative 1x is negative 5x. So here's the function in factored form. X plus 1 times x minus 2 times 2x minus 1 times x minus 2. Can I simplify that at all before I actually put it on the line? Yeah. What could I simplify? X minus 2. Yeah, x minus 2. What could I call it instead? Yeah, x minus 2 squared times x plus 1 times 2x minus 1. Now, Maggie said that there was a 0 that worked at 1/2. Is she correct? Yes. Yeah, the 2x minus 1 shows me that there would be a 0 at 1/2. So now, how can I use this to help me graph? This is similar to what you did on your quiz. It's all coming together. First of all, if I think about the original polynomial, it's a degree of what? 4, and it's positive, so what will be the end behavior? Up, up. I have 0 values at x equals 2, x equals negative 1, and x equals 1/2. So I'm going to plot those. Negative 1, 2, and 1/2. I know it's going to go up and up, so I know up, up. Is it going to pass through or bounce at negative 1? Pass through. How do we know again? The multiplicity is odd, right? It's an odd factor, so it's going to pass through. It's going to the y-axis. How can I determine what the y-intercept is? Plug in 0. So if I plug in 0 for x, then I would have 0 minus 2 squared times 0 plus 1 times 2 times 0 minus 1. What's negative 2 squared? 4 times 1 times negative 1 means my y-intercept is going to be what? Negative 4. So down 1, 2, 3, 4. So it goes down to here. And then is it going to pass through or bounce at 1/2? Pass through. And then what should it do at the 2? Bounce, which stays in line with the end behavior. Good stuff, right? All come together? All right, that's